Hello everyone, in this video I will be solving some problems on constant acceleration and retardation of a body which requires the use of these three equations of motion. So let's begin. The first question says, when brakes are applied to a bus, the retardation produced is 25 centimeters per second squared and the bus takes 20 seconds to stop. We have to calculate the initial velocity of the bus. So we are going to make use of this formula right here. So we write down the formula. V equals U plus AT. V given to us is 0 because the bus comes to a stop. V equals 0. U is not given. We have to find U. And acceleration given to us is the retardation produced is 25 centimeters per second squared. Now retardation is negative of acceleration. So we have to write minus 25 centimeters per second squared. Okay. And it takes 20 seconds. So the time t equals 20 seconds. Now we can also write this 25 centimeters per second in terms of meters as 0.25 meters per second squared, and we can also write this as 1 upon 4 meters per second squared. 1 upon 4 means 0.25. So we substitute all the values in this equation. V equals U plus AT. We get 0 equals U, which we have to find, plus the acceleration, which is minus 1 upon 4th. 1 upon 4, the time 20 seconds. Now we can cancel 4 and 20 5 times, so we are left with 0 equals U minus this minus over here 5. So from here we get U equals 5 meters per second, which is the initial velocity. Okay, the next question wants us to find the distance traveled by the bus during this time, means 20 seconds. Okay, so we are going to make use of the formula V squared minus U squared equals 2AS. Okay, the final velocity given to us was 0 minus the initial velocity which we found in the previous question was 5. We write 5 whole squared. 2. The acceleration was 25 centimeters per second squared. So we can write it as minus 1 upon 4 and the distance which we have to find S. Okay, so if you simplify this, we get 5 squared is 25 equals 2 cancels 4 2 times. So we get minus 1 over 2 times S. The minus sign from both the sides cancels out. This 2 is multiplied with 25, so we get the distance S equals 50 meters. And that's the answer. Let's move on to the next question. A body moves from rest with a uniform acceleration and travels 270 meters in 3 seconds. We have to find the velocity of the body at 10 seconds after the start. So what we do is we first write down the data given to us from the question. A body moves from rest. So the initial velocity of the body equals 0 with uniform acceleration. From this we understand that the acceleration of the body is uniform throughout the motion of the body. And it travels 270 meters in 3 seconds. The displacement equals 270 meters and time equals 3 seconds. We have to find the final velocity of the body after 10 seconds. To find the final velocity of the body after 10 seconds, we have to know the value of acceleration, which we can obtain from this equation right here. So what we do is we write S equals UT plus half AT squared, and then we substitute these values in this equation. We get S equals U given to us is 0, so the whole term becomes 0 plus half acceleration A time t, which is 3 seconds squared. S given to us is 270 meters equals half of A times 9. Okay, so we can cancel out 9 and 270 30 times. So we are left with acceleration A equals 60 meters per second squared. This 2 is multiplied with the 30 here, so it gives us 60. Now we can move on to the final goal of this question, which is finding the velocity. So we make use of this formula right here. V equals U plus AT. We substitute the values that we have. We have to find the velocity V equals initial velocity, which is 0, plus the acceleration, which is 60, and the time 10 seconds times 10. So from here we get velocity V equals 60 times 10, which equals 600 meters. And that's the answer. Let's move on to the next question. A spacecraft is flying in a straight course with a velocity of 75 kilometers per second, fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 kilometers per second in the same direction. There are two parts to this question. The first part of the question wants us to find the spacecraft average acceleration while the motors were firing. So what we first do is we write the data down given to us from the question. We are given that the spacecraft is flying in a straight course, the velocity of 75 kilometers per second. So the initial velocity U equals 75 kilometers per second. Fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 kilometers per second. So final velocity V equals 120 kilometers per second. And the time is 6 seconds. The time t equals 6 seconds. Now this question wants us to find the average acceleration while the motors were firing. So acceleration A equals change in velocity over the time t. So this can be written as A equals final velocity V minus initial velocity U over the time t. Okay, we substitute these values in this equation over here. We get acceleration equals final velocity V, which is 120 minus 75 over the time t, which is 6 seconds. From here we get 120 minus 75 gives us 45 divided by 6. If we solve this, we get 7.5 kilometers per second squared. And that's the acceleration. Let's move on to the next part of this question. The distance traveled by the spacecraft in first 10 seconds after the rocket motors were started. The motors have been in action only for 6 seconds. Okay. So this question says us that we have to find the total distance traveled by the spacecraft in the first 10 seconds. It also states that the rocket motors were in action only for 6 seconds. So we can break down this 10 seconds into first 6 seconds and the last 4 seconds. And we add up the distance traveled in this segment and this segment to get the total distance traveled by the spacecraft. We are going to write down all the data that we got from the previous question. We got that the initial velocity U of the body was 75 meters per second. The acceleration of the body was 7.5 meters per second squared. We substitute these in the formula. S equals ut plus half at squared. Let the distance traveled in first 6 seconds be s1. So S1 equals ut plus half at squared. Now S1 equals the initial velocity, which is 75, the time 6 seconds, plus half the acceleration, which is 7.5, 6 whole squared. So if we solve this equation, we get 75 times 6, we get 450 plus half into 7.5 into 36. Now 36 cancels out by 2 18 times. So the S1 equals 450 plus 7.5 times 18 gives us 135, which equals 585 kilometers. So the distance traveled in the first 6 seconds is 585 kilometers. Before starting to solve the next segment of the question, we have to keep some points in mind, like the initial velocity at the beginning of the second segment, u will be 120 kilometers per second. Now how did that happen? It is given in the question. At the end of this time, its speed is 120 kilometers per second, and also the acceleration would be 0 because the rocket motors were in action only for the first 6 seconds. Now it's really easy to find. The S2 equals ut plus half at squared. S2 equals u, which is 120, time given to us is 4 seconds, plus half acceleration is 0, t squared is 4 squared. S2 would be 120 times 4 gives us 480, plus 0 multiplied with anything gives us 0. So S2 equals 480 kilometers. To find the total distance, we have to add these both. So S equivalent will be equal to S1 plus S2, which is 585 plus 480 kilometers, which gives us 1065 kilometers, and that's the answer. Let's move on to the next question. A train starts from rest and accelerates uniformly at a rate of 2 meters per second squared for 10 seconds. It then maintains a constant speed for 200 seconds. The brakes are then applied and the train is uniformly retarded and it comes to rest in 50 seconds. We have to calculate the maximum velocity reached. What we first do is we write the data down. Because the train starts from rest, the initial velocity u equals 0. It accelerates uniformly at a rate of 2 meters per second squared. So the acceleration equals 2 meters per second squared. It accelerates for 10 seconds. So the time t equals 10 seconds. Now let v be the maximum velocity reached by the train. So we have the formula v equals u plus a times t. The final velocity v equals initial velocity 0 plus acceleration, which is 2 meters per second squared, 2 times 10. So v equals 10 times 2 gives us 20 meters per second. That's the answer of the first part. Let's move on to the next part. The next part wants us to calculate the retardation is the last 50 seconds. It's obvious that after retardation, the final velocity v would be 0. The initial velocity u will be 20 meters per second. We have to find the retardation is the last 50 seconds. So we make use of the formula acceleration is equals to delta v over time t. Delta v is nothing but final velocity minus initial velocity over the time t. We substitute these values in this equation. We get final velocity v equals 0 minus the initial velocity, which is 20 meters per second, over the time t, which is 50. So it's minus 20 over 50. If we solve this, we get minus 0.4 meters per second squared. And that's the retardation of the train in the last 50 seconds. This question wants us to find the total distance traveled by the train. So let us first break down the segments in which the train has traveled. The train starts from rest and accelerates at a rate of 2 meters per second squared for 10 seconds. So the first segment is 10. It maintains a constant speed for 200 seconds. The next segment is 200 seconds. And the brakes are then applied and the train uniformly retards and comes to rest in 50 seconds. So the final segment is 50. So we have to find the distance traveled in this, this and this. We add up everything and we get the total distance traveled by the train. Let S1 be the distance traveled in the first 10 seconds. So S1 equals UT plus half AT squared. S1 equals initial velocity would be 0 because the body has started from rest. So 0 multiplied with anything gives us 0 plus half acceleration is 2 seconds in the first segment. So 2 and time is 10 seconds. So 10 squared. The 2 cancels out with 2. So we are left with S1 equals 100 meters. Now for the next segment, S2 equals UT plus half AT squared. S2 equals the initial velocity, which is 20 meters per second. The time given to us is 200 seconds plus half into acceleration. This segment of the question also says that it maintained the constant velocity for 200 seconds. So the acceleration would be 0 and the times t squared. So S2 equals 200 times 20 gives us 4000 plus 0. So S2 equals 4000 meters. The distance traveled in the third segment would be S3 equals UT plus half AT squared. So S3 equals the initial velocity would be 20 meters per second as it did not change its velocity across the second segment. So 20 times the time 50 plus half, the retardation would be minus 0.4 and the time 50 squared. Now this equals S3 equals 50 times 20 gives us 1000 plus half times minus, now 0.4 can be written as 4 over 10 for easier calculation. 50 times 50, 0 cancels out 0, 2 cancels out 4 2 times. So S3 equals 1000 minus 5 times 2 gives us 10 and 50 times 10 is 500. So S3 equals 500 meters. So the total distance covered by the train would be S equals S1 plus S2 plus S3, which equals 100 plus 4000 plus 500, which gives us 4600 meters. So the total distance traveled by the train would be 4600 meters. Let's move on to the next question. This question wants us to find the average velocity of the train. We know that average velocity V is total distance upon total time taken. Okay, so the total distance was we found in the previous question, which is 4600 meters, and the total time taken would be the summation of 10 plus 50 plus 200. Now that would give us 260 seconds. So we write 260 seconds. If we divide this, we get 17.69 meters per second, and that's the answer. Thank you for watching Integrated Pi. I am Kaustubh Dev.